Hello, this is Mr. Henry, and this is lesson 2.4, the Pythagorean Theorem. The essential question says, how do I use the Pythagorean Theorem to solve problems in both 2 and 3 dimensions? So if you remember in the last lesson, what we talked about was using the Pythagorean Theorem to find the missing side of a right triangle. Well, this lesson is just an extension of that. We're going to be using that same idea and finding missing lengths of various different problems where we can draw a right triangle to help us solve the problem. The warm-up says, do you think Pythagorean theorem could be used to find the distance from home plate to second base on a baseball diamond? It might help to know that each side of the diamond is 90 feet. Why or why not? So hopefully you might have had a chance to think about that and try it yourself. If you didn't, maybe pause it and make a little doodle on your paper. So here I'm going to make an attempt. So I'm not going to do the whole problem. I'm just going to show you how, yes, the Pythagorean theorem can be used to do this. So we're trying to find the distance from home plate here to second base here. And the fact that you know that each side of the baseball diamond is 90 feet and each of these corners is a right angle, look what we have. On this side of the triangle, we have a right triangle with two legs of 90, so 90 squared plus 90 squared equals the hypotenuse, x squared. And then we do the normal Pythagorean theorem problem that we did previously. 90 squared plus 90 squared, take the answer, square root each side, and we'd get our answer of whatever it is. Okay? So it sometimes is, well, in these problems you're going to find it's extremely helpful if you draw a picture to represent what the problem is asking us to do. And that's what most of our focus is going to be about. The only vocabulary here, it's the same vocab we've had in the past. It says Pythagorean theorem is this: a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. So the c is the longest side, the a and the b are just the other two sides. In every one of these problems you're going to see, I think every single one of them are going to be word problems, story problems. So let's get to it. The first one here says, Jose is going for a run. He's going to run west for 4 miles. So he starts here. He runs west 4 miles. Then he turns south, and runs another 8 miles. How far is Jose from his starting place? So here's Jose, and here's where he started. We want to know, how far is Jose from his starting place? Now, if you did exactly what I did, and you drew the picture as we were reading the problem, this is a very simple problem. It's a right triangle. I know two legs, the 4 and the 8. I do not know the hypotenuse, c. So when I set up my Pythagorean theorem, a squared plus b squared equals c squared, I get 4 squared. It's doing that little bugger again, huh? 4 squared plus 8 squared equals c squared. 4 squared is 16. 8 squared is 64. C squared. 16 plus 64 is 80. 70, 80, yeah. And then to get our answer, we square root each side. And c equals 80 square root 8.9. 8.9. And this would be in miles. So the distance that Jose is from where he started is 8.9 miles. If you did not draw a picture and you're trying to think and it may not make much sense. I really recommend drawing a picture for every single or almost every single word problem. This letter B, I'd like you to try. Make sure you draw a picture. It says a 25-foot ladder is leaning against a wall. If the base of the ladder is 7 feet from the wall, how high up the wall does the ladder reach? Draw a picture, label the parts you know, and even the parts you don't know, and try to find out how high up the wall the ladder reaches. Pause the video, do it now. When you're ready to continue, hit play, and we'll go through it together. Okay, so that is horrible. That's less horrible. Okay, so we start with our picture, and we have our ladder leaning against the wall. It says the 25-foot ladder, so it's 25 feet, and if the base of the ladder is 7 feet from the wall, here to here is 7 feet. How high up the wall does the ladder reach? What is this distance? I don't know. But if you looky, I can maybe, red here. This makes a right triangle. There's our right angle. So, Pythagorean theorem again. A squared plus B squared equals C squared. Now, this is the longest side since it's across from the right angle, which means that is the C. The 7 feet, one of the other sides. And the missing piece, well, he's going to stay missing for a little bit. And let's not forget our squared here. Alright, so simplify both sides. 49 is 7 squared. 25 squared is 625. I'm going to subtract both sides by 49. And I get A squared equals 625 minus 49. Always in the wrong place. 625 minus 49 equals 576. And then to get the variable by itself, we're going to square root each side. And we get 24. So this missing side is 24 feet long. How high up the wall does the ladder reach? The answer is 24 feet. Letter C. It says a room is 8 feet tall, 12 feet wide, and 15 feet long. Ah, nice. We have a little picture down here. 8 feet tall, 12 feet wide, 15 feet long. Sweet. If a bee were to fly from the bottom corner the bottom corner of the room straight to the opposite diagonal corner at the top, what distance would the bee fly? So the first thing I would do is I would draw a picture of what I want to find. So I have this line here. I need to make a right triangle. So I'm imagining the room, and the right triangle that I imagine is down this wall and then across here. So this would actually be a right angle. Something like down the wall and then straight across the floor and this diagonal. So this is the diagonal that I want to find. I need to know what this side is. That's what the question is asking. What distance would the bee fly? That distance here. Okay. So from this triangle, I know this side here is 12 because it's the same height. I'm sorry, no. That height of the room is 8, not 12. So the height of the room is 8 feet. See? 8 feet. Now this diagonal. Well, I don't know that diagonal. I don't know how long it is, but I can find it because this now I have this side, and that side make a right triangle. This side is 12, that side is 15, that side, I don't know, we'll call it X, is my missing piece. So look what we have here. We have a right triangle with missing piece X. When we find this piece, we can plug that into our big right triangle and find the missing piece C, and this is what we need for our final answer. That is our goal. So the process I went through to get here is I looked at my big triangle, the red triangle, and I plugged in what I knew. Now, since there were two pieces I didn't know, I had to look to see how can I find one of those pieces. Well, since this guy is the final goal, that's the last thing I'm going to find. So I should be able to find this. So I look for another right triangle possibly, or a way to find out this length. And I saw because this room's a rectangular prism, I have a right triangle made by the length and the width and that diagonal. So let's do a couple Pythagorean theorems. I'm going to do the first Pythagorean theorem for this blue triangle. A squared plus B squared equals C squared. Since this is across from the right angle, that is the hypotenuse, so I do not know that. The A and the B are just going to be the 12 and the 15. 12 feet squared plus 15 feet squared equals x squared. 12 feet is 144. 15, I believe, is 225. Clear. 15 squared, 225, equals x squared. 144 plus 225, 369. And if I square root each side, x equals square root 19.2. So this x, this distance here, is now 19.2 feet. And I needed that so that I could do this red triangle. So now I have a squared plus b squared equals c squared. The c here is the hypotenuse of this right triangle. That is the length I'm trying to find. That is the final answer for the problem. A I'm going to make as 8 squared. B is this other side, this 19.2 I found in the first problem. Squared. So 64 plus 19.2 squared. What was that? 369? Yeah. I'll just round it, I guess. 19.2 squared, 368.64. Equals c squared. I'm adding the 368.64 plus 64 equals 432.64. And finally, square root each side. C equals square root 20.8 feet. So if that B were to fly diagonally straight across the room from the bottom corner to the diagonal top corner, it would go 20.8 feet. So this was an example of that three-dimensional Pythagorean theorem problem. There's lots of varieties of ways these problems can be set up. This is one of the most common ways where you're given a cube and you have to find this diagonal distance of the cube. Hint, hint, you might see this again. Here you are, letter D. Try this one on your own. It says a crow and a robin fly away from the same tree. The robin flies north 6 miles and the crow flies south 10 miles. Both birds turn to their left and fly 5 more miles. How far are the birds from each other? So, I would like you to pause the video, try the problem on your own, definitely draw a picture. When you're ready to continue, hit play, and we'll go through it together. Alright, so I'm going to start with, here is my starting point. Now, my crow flies south 10 miles, and my robin flies north 6 miles. Then they both turn to the left. So here's my robin. He's like facing north. His wings are out. So if he turns left, he's going that way. And he goes another 5 miles. My crow would be facing this way. Wings out. So if he turns left, he's turning that way. And he goes this way. 5 miles. How far are the birds from each other? What is this distance? And no, I can't guarantee it actually goes through this center point. My picture's not very good. So, you look at this and you think, okay, how can I figure out this distance? No, you cannot assume that it goes through the center point and just do 5 and 6 right triangle, 10, 5 right triangle, and add those two lengths together. That probably won't work. It might get you close to the right answer, but my guess is it's actually not going to be the actual final right answer. Well, how far are the birds apart from each other going north and south? If I went like straight up, they're a total of 16 miles apart, north and south. How far are they east and west? So 16 this way, and a total of, 5 here and another 5 here, making a total of 10 miles east and west. You kind of see what I did here? If I go, I'm out of colors. We'll use pink. Alright. So if I take this and I go up 16 miles and over 10 miles, that gets me from where the crow is to where the robin is. That's a little bit easier to see. I went north 16 and this way 10. That right there is the trick to the whole problem. Being able to draw a right triangle that represents the problem. Now that we have this, the problem is simple. Because it is a right triangle, you're just trying to find this other side, and then you use the Pythagorean theorem to do it. A squared, b squared, c squared. This is the hypotenuse. I already labeled it as c. I did that instinctively. But yeah, that is the hypotenuse. That's the side we're trying to find. The other two sides would be this 10 squared and the 16 squared. 10 squared is 100. 16 squared, I have no clue. 16 squared, 256. Add that together gives me 356. That's going to be around 19, I think. Add 100. Square root 18.86. 18.87 if you round it to the nearest hundredth. 18 point, what did I say, 87? Yeah. And that's if you square root each side equals that. So the distance the two birds are away from each other is 18.87 miles. Draw a right triangle that represents the problem. This is where you have to be a little bit creative in your math. We're on letter E. It says a sofa is in the shape of an L. Okay, so already in my head, I'm imagining a picture. So I've got maybe like that, or for using an L, maybe I'll just flip it horizontally. Flip, left, right. There you go. Sofa's in the shape of an L. The long side of the sofa is 14 feet. If a man were to throw a pillow from one end of the short side, so he's throwing a pillow from here. That's a terrible pillow. Let me try that again. I'm sorry you had to see that pillow. Better. So you had to throw this pillow from one side of the short side to the end of the long side, and the pillow traveled 17 feet. So the pillow goes from here to there, and it went 17 feet. How long is the short side of the sofa? Well, looky here. We got ourselves a right triangle. So we use Pythagorean theorem. A squared, B squared equals C squared. A squared is 14, B squared is 17. Whoa, don't forget your squares. Equals C. Oh, I messed up, didn't I? Because this 17 is the hypotenuse. He belongs over here. This B, I don't know, so I'll leave it as B squared. And some math. 14 squared is like 196. 14 squared is 196. This pen is messing up on me. 196 plus B squared. 17 squared. 17 squared is 289. 289. To get the B by itself, I have to subtract this 196, so I'm going to do that on both sides. 96 gives me B squared equals 289 minus 196 equals 93, and so my square root's going to be just above 9. Because I know my perfect squares, and they're 81 and 100, and this guy's pretty close to 81. Actually, it's about halfway, I guess. Like 9.5. 93 square root, 9.6. So the short side of the sofa is about 9.6 feet long. Draw a picture. It really helps. Now, one thing I want you to notice, in every single problem we've done so far, A, B, C, D, E, we've done 5 in this lesson. In every single problem, the Pythagorean theorem has been used to find a distance from one place to another. Most of the problems you're going to see that involve you finding a distance are going to involve the Pythagorean theorem. I can't say every problem because there's problems that involve using a distance formula, and there's a variety of different ways you can do different problems, but I can tell you right now, a large chunk of the problems you're going to see that involve you finding a missing length are probably going to use Pythagorean theorem. So when you see a problem where you're finding a missing length of something, and it gives you other information like one piece is 14 feet, another piece is 17 feet, draw the shape, and then you might be able to recognize it as, hey, that is a right triangle. Yes, I can use Pythagorean theorem. For example, letter F says the diagonal measurement of a door is 91 inches. The height of the door is 84 inches. What is the width of the door? The second part says, what is the area of the door? Go ahead, pause the video, do both problems right now, and when you're ready to continue, hit play, and we'll go through them together. Alright, so I really hope you did draw a picture of a door, and it said the diagonal distance here was what, 91 inches. The height of the door is 84 inches. What is the width of the door? We don't know that. That's what we're trying to find. That's what the first question asks us to do. And because this is a door and doors are made with right angles, we have now a right triangle using the width, this diagonal distance, and the height. Therefore, you take those distances, you plug them into the Pythagorean theorem, and you find the missing side. A squared plus B squared equals C squared. Now, make sure I don't mess up again. Diagonally across in the right angle, that is the hypotenuse. 91 squared. 84 is my one leg, and this width is the other. Alright, let's go to town on this thing. 84 squared. Clear. 84 squared. It's frozen. Oh no. Click. There we go. 7056. 7056 equals, and 91 squared. 91 squared is 8218 or 8281 W squared. Alright, and we have to subtract the 7,000. That's the pen being stupid. We have to subtract this 7,056 W squared equals 8,821 minus 7056 equals 1,225. It was, yep. And then when I square root each side, I'm going to get W equals 35. So this door was 35 inches wide. We are almost done. We did the first part of the problem. What is the width of the door? The width of the door is 35 inches. What we did not do is the second part of the problem that says what is the area of the door. Now, on something like a PSSA, they may not even ask that first part of the question about what is the width of the door. They may jump straight to, here's the diagonal distance, here's the height, what's the area? And you have to know, to find the area of something, the area of a rectangle is length times width. They tell me the height, or the length. I need to find the width. So you do the Pythagorean theorem to find the width, then you can plug it into your area formula. Let's do that. The length here is 84, or the height, depending on how you want to think about it. The width is 35. So my area, 84 times by 35 equals 2,940. 2,940 inches squared. That is the area. That is the width. Inches. If you could please answer this summary question in the summary box of your note sheet. It says, how do you use the Pythagorean theorem to solve real-world problems? Go ahead and pause the video right now and do it on your own. When you're ready to continue, hit play, and we'll go through it together. So here's what I came up with. I say the Pythagorean theorem can be used to find distances in real-world problems where a right triangle can be drawn. It's used to find a distance, it's used to find the length of a missing side, and if that missing side happens to be a distance between maybe two cities, well, there we go. We can use the Pythagorean theorem to find the distance between two cities if you know two of the other sides of that right triangle. This has been lesson 2.4. Thank you for watching.